everybody, this is me Vinu Venkatesh again, on behalf of Sai Education for Comparative Examinations. So we're going to start a new topic today. It's called Surds and Indices, and let's get started. Okay, it is since we have done square roots and cube roots, I think, and it's fresh in our minds, we can continue with this. I mean, it'll be easier for us to do this, right? So what is a surd? Surd are irrational roots of an integer. Okay, irrational roots of an integer. For example, root of 7, root of 11, root of 45, which are not perfect squares. Those are called surds. But root of 81, what is square root of 81? It's 9, remember? As I said, I repeat, please learn the squares of numbers 1 to 25 and also the cubes of numbers 1 to 25, so that it will be easier for you to attempt the questions, since calculators are not allowed. Root of 81, since it's a perfect square, it is not a surd. Root of 121 is what? 11. It is also not a surd because it is a perfect square. So surds can also apply to cube roots. For example, what is cube root of 100? It is not a perfect cube. 100 is not a perfect cube. It is a perfect square. 10 square is equal to 100. Therefore, cube root of 100 is a surd because it is not a perfect cube. But square of 100 is not a surd. Why? Because 100 is a perfect square. Therefore, square of 100 is a whole number, which is 10. But cube root of 100 is not a whole number, and therefore it is a surd. Okay. So wherever you don't get a whole number as a square root, square root of a number or a cube root, then such terms are called surds. Now, what we are going to do now is there are certain rules that we have to study in square roots and cube roots. We in fact did it indirectly in our previous lecture, but now we are going to do it more directly, so that it will be easier for you to understand. And please learn these rules by heart, memorize them, please. It's very important. You cannot solve questions without knowing these rules. Okay, for example, what is square root of 7 into square root of 7? First of all, is this a surd or not? It is a surd because the square root of 7 is not a whole number. Why? Because 7 is not a perfect square. Okay, so what is square root of 7 into square root of 7? We can directly multiply it, right? You can see square root of 7 into square root of 7 is nothing but square root of 40. Square root of 7 into square root of 7 is nothing but square root of 49. Now, what is square root of 49? We know that 49 is a perfect square and square root of 49 is 7. Understood? So when you're given two numbers like this for multiplication under square or cube roots, you can directly multiply them. That is, square root of, for example, 5 into square root of 7 is what? Square root of 35. So square root of 5 into square root of 7 is square root of 35. Cube root of 10 into cube root of 900 is equal to cube root of 9000. Okay, so you can directly multiply what is there under these terms. Alright, okay, rule number 2. Let's move to question number 2. 7 into root 5. Here, since the answer is 7 root 5, okay, it is not, you cannot do it this way. 7 into root 5 is 7 root 5. It is not equal to root of 35. Why? Because 7 is outside the square root sign. Therefore, I cannot take it inside the square root and multiply by 5. Only if it was root 7, then I can write root 7 into root 5 is root 35. But since 7 is outside the square root sign, I cannot take it inside the square root and it has to remain outside the square root, and the correct answer would be 7 root 5. Okay, so this is not equal to root of 35. To get root of 35, it should be root 7 into root 5. Okay. Now, number 3. Root 3 into root 7. This is similar to the first question. It is nothing but root of square root of 3 into 7, which is equal to root of 21. Since both are in the square root, under the square root symbol, I can multiply them like this directly. But if it is not, I'll have to follow this second rule. Okay. Now, third rule. 5 root 3 plus 4 root 3 is equal to 5 root 3 plus 4 root 3 is equal to 9 root 3. I can add these terms because the number in the square root under the square root is the same. If it was cube root 3, if it was 5 cube root 3 plus 4 cube root 3, I can still add it because the number in under the cube root is the same. If it was not the same, I could not have added it. Okay, remember. So addition, you can add square roots and cube roots as long as the number in the square root for all the terms or the number in the cube root for all the terms is the same. Okay, so that is the third rule. Now question number 5 is similar to number 4. 8 root 3 minus 2 root 3. Same principle, addition and subtraction of roots. We can do it only if the number in the square root for all the terms or the number in the cube root, if it is cube root for all the terms, are the same. In this case, it is root 3 here and root 3 here, so we can subtract it. How do we subtract it? The same way we did number 4. 8 root 3 minus 2 root 3 is nothing but 8 minus 2 root 3, which is 6 root 3. Okay, so it's the same principle for addition and subtraction. Okay, now number 6, root 5 plus root 3 whole square. Now remember, we have learnt the a plus b whole square formula, right? What is the formula? It is a square plus b square plus 2ab. What is a here? Root 5. What is b? It is root 3. So a square plus root 3 whole square, which is b square, plus 2 into root 5 into root 3. Now in our previous lecture, I had said that square root of 5 or square root of any number can be written as that number raised to 1 by 2, right? So this would, square root of 5 can be written as 5 raised to 1 by 2 brackets 2, which is whole square. Similarly, 3 raised to 1 by 2 brackets raised to 2, which is whole square, plus 2 root 15, 5 into 3, root 5 into root 3. So here the 2 and 2 get cancelled. You know, this is a rule of exponents. Here also 2 and 2 get cancelled. So this becomes 5 plus 3 plus 2 root 15, which becomes 8 plus 2 root 15. Now can I add this? Can I write this as 10 root 15? Because it's 8 plus 2, right? 8 plus 2 root 15. Can I add it? I can't add it. Why? Because 8 does not have any square root term. In fact, 8 does not have the term square root of 15 here. So I cannot add these two terms directly. I have to leave the answer like this. If the answer was 8 root 15 plus 2 root 15, then I can say it is 10 root 15. But since 8 is a whole number and it is by itself, it does not have a root of 15 symbol, then I cannot add this together. Okay, number 7 is similar. Root 7 minus root 3 the whole square. So this is similar to a minus b whole square. Remember, what is the formula for that? It is a square plus b square minus 2ab. What is a here? Root 7 plus root 7 whole square plus root 3 whole square plus 2 into root 7 into root 3, which is 7 plus 3 minus root 2 root 21 minus 2 root 21, which is 10 minus 2 root 21. This is a typo. It is not equal to, it is minus here. Okay. So same principle as this. Remember the formula. Okay, now let's move to number 8. 1 by root 7 minus root 5. First off, let me ask you, can I write this as 1 divided by root 2? I can't write it. Why? Because the terms, the number under the square roots are not the same. So I cannot subtract it directly. Remember, for addition and subtraction, we said that the number under the root, whether it is square root or cube root, has to be the same. Only then we can subtract the two terms or add the two terms. Remember? So here I can't do anything. Then how do I solve this question? Oops, I have lost my grandfather is right. There you go. So in such a case, the formula is, it can be written as 1 divided by root a minus root b. You multiply the numerator and denominator by root a plus root a plus root b. Whatever sign here there is, multiply this numerator and denominator by this entire term, same term, except with the opposite sign. So since here it's minus, it has to be multiplied by plus on top as well as the bottom. So top becomes root a plus root b divided by a minus b. How did I get a minus b? Because this is the formula, another formula that we learned. A minus b into a plus b is the same as a square minus b square. So root a square minus root b square is what we will give here. We know that root a square is nothing but a and root b square is nothing but b. So we get this term. So 1 divided by root 7 minus root 5 would be nothing but root 7 plus root 5 divided by 7 minus 5, which is 2. I cannot add these two terms because the term under the square roots are not the same as per our rule, remember? So I have to leave it as it is. Question 9 is also similar. Here only the sign, same method, but the sign here has to be different. Okay, I leave you to try it on your own. So we will end the lecture for here today. We'll start with number 10 in the next class. Please keep practicing. Please learn the formulae, because without that you cannot solve these problems. So all the best. Take care and see you soon.